So we saw useEffect in action here in the scenario with no dependencies. Now, often you need dependencies because you don't just want to run this effect function once when the app starts up, but indeed after every component reevaluation if a certain dependency changed. And an example can be found in the login component. That's the component where I actually render this form here. That's being rendered here. And as you see, there is actually some validation built in. If I click in here and I click out, you, for example, see this is marked as red. And also the button is only enabled if I have entered something valid in both inputs here, right? So otherwise, the button is disabled. So we got some validation, and currently, the validation works such that for every keystroke on the email field, this email change handler runs, and it sets the form as valid if the email contains an @ symbol and the entered password was correct. And we get the same for the password change handler. And I also got the validate email handlers where I set email and password as valid whenever the inputs blur, so whenever they lose focus, so that they also are marked as invalid if I just click in there, enter nothing, and click somewhere else. Now, where could we use useEffect here? Well, for example, to restructure our validation logic here. Instead of having essentially the same logic, just, well, swapped basically, in the email and the password change handler, we could use useEffect to have one place where we mark the form as valid or invalid with one logic, which should trigger whenever either the email or the password changed. And that's where we will need an extra dependency. So therefore here, we can again import useEffect. And then here, after our state definitions, we can call useEffect and pass this first function to it. And have our array of dependencies. Now in this first function, I will call setFormIsValid. But of course, I will not use the event target value, but I will check if the entered email includes the @ symbol and the entered password is longer than 6 characters. Now, like this would only run once, and that's when this component first is rendered. So therefore, if I remove that logic from the password and the email change handler, you will see that I can reload this and I can type in there. And my form, well, this button never gets enabled. And the reason for that is simply that this effect only ran once, as I said, when the component rendered for the first time. Now, that was the right behavior in the app component with our login state. It's definitely the wrong behavior here, though. We want to reevaluate this and rerun this form validation state setting function for every keystroke in email and password change handler. Now, we could remove the dependencies array. Now, don't save this because this would crash your page. This would make sure that this runs whenever this component was reevaluated. Therefore, effectively, in this case, it's the same as if we would have moved this code directly here into the component function itself. Because now, without any dependencies, this code reruns whenever the component was re-rendered. And since we set state in here, this would trigger a re-render cycle itself. Hence, we would have an infinite loop. So saying nothing about the dependencies is not what we want. But no dependencies is also not what we want. Then it would only run once. Well, indeed, there is a simple rule. You add as dependencies what you're using in your side effect function. So in this case, we are using the setFormIsValid function, we are using entered email, and we are using entered password. Includes and trim are only called on those entered email and entered password fields then. So we have setFormIsValid, entered email, and entered password. These are our 3 things we're using here. So therefore, here, between these brackets, you would add setFormIsValid, entered email, and entered password, just like this. important for setForm is valid, you of course don't execute it. That would add the result of this function execution as a dependency. But instead you add it like this to add a pointer at this function, so that you essentially add the function itself as a dependency. And this tells React that after every login component function execution, it will rerun this effect function, but only if either setForm is valid or entered email or entered password changed in the last component re-render cycle. If neither of the three changed, this effect function will not rerun. Now actually, you can also omit setForm is valid because those state updating functions by default are ensured by React to never change. So these functions will always be the same across re-render cycles, so you can omit them. Entered email and entered password could have changed, of course. To be precise, with every keystroke, one of them will change. So if we now save this and we try this again, you see the login button still enables and disables. And the reason for that is that now this effect function reruns whenever entered email or entered password changed. So that's another scenario where useEffect shines. It helps us make sure that we have one code in one place instead of, as before, in multiple places, which reruns whenever one of the dependencies changed. And that's also something where you use useEffect. So it's not just for when a component was created for the first time, but it's equally common to use it to rerun logic when certain data, typically some state or some props, changed. Now, one aspect that could be confusing here is that, of course, now inside of this useEffect example, we're not working with local storage, we're not sending a HTTP request, we're not setting a timer or anything like that. Instead, we are updating the React state. And that could be confusing if you recall that slide from earlier, where I had a slightly different separation. So to clear that confusion, you must not forget that it's called useEffect, and it has one main job. It's there to handle side effects. And often, side effects are HTTP requests and so on. But it's also a side effect if we listen to every keystroke and save that entered data, as we're doing it in the email change handler, for example, and we then want to trigger another action in response to that. So checking and updating that form validity in response to a keystroke in the email or password field, that is also something you could call a side effect. It's a side effect of the user entering data. So that's why this should not confuse you. useEffect in general is a super important hook that helps you deal with code that should be executed in response to something. And something could be the component being loaded, it could be the email address being updated, it could be anything. Whenever you have an action that should be executed in response to some other action, that is a side effect. And that is where useEffect is able to help you. That's just a little addition I want to make here. Now, there is one last important thing you need to know about useEffect, or about the built-in features of useEffect. We learned about this effect function, we learned about the dependencies with the scenario that we have no dependencies with an empty array, or that we have some dependencies. Now, sometimes you also have an effect that needs to do some cleanup work. And that sounds very abstract, so let me give you a more concrete example. Let's say here, we're executing this function essentially on every keystroke. This is what happens here. I can prove this to you. If I console log this, checking form validity, you will see, if we go back here to the console, with every keystroke, this runs. Now that's not a problem here. This function execution is fairly fast, but what you do in this function, that might be a problem. Here we are updating some state. This might already not be ideal. Now I'll be honest, for this simple state update it won't be a problem, but of course it means that it triggers another function component execution and that React again needs to check whether it needs to change something in the DOM. So even that might not be something you really want to do for every keystroke. Now imagine you would do something more complex, like for example, send a HTTP request to some backend where you check if a username is already in use. You don't want to do that with every keystroke, because if you do, that means you're going to be sending a lot of requests. And I don't know about you, but that might be a lot of unnecessary network traffic. So that's something you might want to avoid. And as I said, even this year, this state updating is something you might not want to do on every keystroke. Instead, something you might want to do is that you collect a certain amount of keystrokes, or you simply wait for a pause of a certain time duration after a keystroke. And only if the pause is long enough, you go ahead and do your thing. So for example here, whilst the user is actively typing, I might not want to check if it's a valid email address. I care about when the user stopped typing. So for example here, when I type and then I stop for, let's say, 500 milliseconds or longer, then I want to check, okay, the user seems to be done, let's see if it's valid. That's something we might want to do, and the same for the password. Now that's a technique which is called debouncing. We want to debounce the user input. We want to make sure we're not doing something with it on every keystroke, but once the user made a pause during typing. And with useEffect, that's actually easy to implement. We can use setTimeout, which is a function built into the browser, to wait for example, 500 milliseconds until we execute some function. Now, in this function, we might want to check our foreign validity, or to update our foreign validity. Now we would only do this after 500 milliseconds. Now, if I move my console log in here, you will see that this alone doesn't do much. The only result is that we don't see the output immediately, but with a slight delay of 500 milliseconds. Which makes sense because for every keystroke, we're now setting a timer, and after 500 milliseconds, we do this. Well, the trick is that we actually save the timer, and for the next keystroke, we clear it so that we only have one ongoing timer at a time. And only the last timer will therefore complete. And as long as the user keeps on typing, we always clear all other timers. And therefore, we'll only have one timer that completes, and that completes after 500 milliseconds, which is the delay the user has to issue a new keystroke to clear this timer. Now that might sound complex to implement, but useEffect makes that very easy actually. In the useEffect function, so the function you pass as a first argument, you can do something we haven't done before. You can return something. Now the something you return here has to be one specific thing. It needs to be a function itself. So here you can also return a function. For example, an anonymous arrow function. But it could also be a named function, just as for all the places where I'm using anonymous functions. So we are returning this anonymous arrow function here. That's a so-called cleanup function. This will run as a cleanup process before useEffect executes this function the next time. So, to make it clear when this runs, whenever this useEffect function runs, before it runs, except for the very first time when it runs, this cleanup function will run. And in addition, the cleanup function will run whenever the component you're specifying the effect in unmounts from the DOM, so whenever the component is reused. So the cleanup function runs before every new side effect function execution and before the component is removed, and it does not run before the first side effect function execution. But thereafter, it will run before every next side effect function execution. So we can simply console log cleanup here to get a feeling for when it runs. If I reload this page, you see checking for invalidity ran. So this code ran clearly, our main side effect function code, but we don't see the cleanup call. We don't see the cleanup log because of what I said. It does not run before the very first side effect execution. But if I then type here just one character, you see cleanup runs immediately, and then the code inside of this side effect function, inside of this function here, this code here executed. So that's how cleanup runs. It runs before every new side effect function execution. So with this in mind, we can use the fact that setTimeout actually returns a handler, let's say, or actually an identifier for the timer that was set. And we can use this identifier to clear this timer with the built-in clear timeout function, which is built into the browser. So this has nothing to do with effects or with React. This is built into the browser. Now I don't want to run it here. I want to run it in my cleanup function instead. There I call clear timeout and pass the identifier of this timeout to it. And this makes sure that whenever the cleanup function runs, I clear the timer that was set before this cleanup function ran, so in the last side effect function execution, so that when the next side effect execution is due, we are able to set a new timer. So we clear the last timer before we set a new one. That's what's happening here. And again, if the order is not clear to you, have a look at those console log statements, this one, and see in which order they execute. So therefore now if I reload, we see checking for invalidity. And now if I type here, cleanup, and then again checking for invalidity. But now here if I type a lot very quickly, you see a lot of cleanups, but you only see one checking for invalidity. Again, let me show this to you. If I clear this, and now again, if I type quickly, only one checking for invalidity. And that means that this code in here only ran once for all those keystrokes. And that's what I mentioned earlier. If we would be sending an HTTP request here, we would have now only sent once instead of a dozen HTTP requests. And that's an improvement. And of course, also a nice example for this cleanup function and when it matters and how it works. And of course, needless to say that our form here still works as before, just with a slight delay, which you of course can control. You can lower this number here, fine-tune it to your needs. But this is a great example for the cleanup function and how it works. UseEffect, besides useState, is the most important React hook you have, so you need to understand it. Therefore, I again want to make it clear at which point of time, which part of UseEffect kicks in and executes. And for this again here in the login component, I'll add a new UseEffect call where I only add this first argument. So for the moment, no second argument. And in there, we can log effect running. Now, at the moment, we have no information about the dependencies. We just have this first argument. And this is a valid way of using it, though you will rarely use UseEffect like this. The reason for this is that if I reload, you see it runs when the component first mounts. So when this login component is rendered for the first time. But then also for every state update. For example, if I click in here and click out of there, we see effect running. For every keystroke, we see effect running. So this really now runs for every time this component function reruns, because you learned this effect function runs after every component render cycle. Not before it and not during it, but after it, including the first time this component was mounted. Now, this changes once we add an empty array. Now, this function here only executes for the first time this component was mounted and rendered, but not thereafter, not for any subsequent re-render cycle. So we see effect running here, but for the keystrokes, we don't see it. Now, if I log in, we also don't see it again. So it really only ran once. Alternatively, we add a dependency like entered email or entered password. Now this function here reruns whenever the component was re-evaluated and this state in this case here changed. So if I now log out and reload, we see effect running for the first time this was mounted. But now for keystrokes in the email, nothing changes. For keystrokes in password, we see effect running though, because the password is a dependency. We also have the cleanup function, which we can return. This cleanup function runs before this state function as a whole runs, but not before the first time it runs. So here I will again log effect cleanup, save this. We see only effect running here for the first render cycle. For the email, nothing happens. That's a different cleanup log. This is coming from our other effect. So effect cleanup did not print yet. But once I start typing in the password, we see effect cleanup being triggered, and it triggers before the effect function runs. Now, if we had an empty array here, so no dependencies, we learned that we only see effect running once, and the cleanup function in this case would run when the component is removed. So in this case, for example, when I log in and the component is removed from the DOM, we see effect cleanup. So that's how useEffect works and how the different parts of it are related and when they execute. Really important to understand this. So if it's not 100% clear at this point, definitely go through those last lectures again to make sure it is clear. Now we just learned about useEffect, which I mentioned would be the most important React hook besides useState. Are you ready for the next React hook, useReducer? Now, useReducer is another built-in hook, and it will help us with state management. So it's a bit like useState, but actually with more capabilities and especially useful for more complex state. Because sometimes you have more complex state, for example, multiple states that kind of belong together, that are managing the same thing, just different aspects of it. Or you have multiple states that kind of change together or are related. In such cases, useState and the state you get from there often becomes hard or error-prone to use and manage. And it's easy then to write bad or inefficient or potentially buggy code, which is, of course, never what we want. useReducer is then an alternative to useState, so it's a replacement if you need a more powerful state management. Now, this does not mean that you should always use useReducer, because it's more powerful, so it's always better, right? No, because it's also a bit more complex to use, it requires a bit more setup. So for a lot of scenarios, for the majority, I would argue, you probably use useState. But there are cases where the extra work of getting useReducer to work is just worth it. That's all very abstract. What would be a concrete example? We can again go back to the good old login.js file here. Here, you see, I'm managing a couple of state snapshots, and you might be able to spot some related state here. We manage the entered email and the entered password, but then we also manage the fact or the question, the response to the question, whether the email or the password is valid, and we manage the overall form validity. So you could argue that overall, this is all one big state that describes the overall form state. The inputs are part of that. Or you at least treat every input as one entity and one state, which simply has two aspects: the value the user entered and the validity of that input. And it becomes clear that we have some work to do and some redundancy if we consider the fact that we're setting the overall form validity by checking the validity of email and password when we're doing the exact same thing here for our two validate handlers. Now we could rewrite this in various ways and, for example, use our email is valid and password is valid states here in this useEffect and just use those two states to confirm whether the overall form is valid, and that would work. But nonetheless, we at least have these two states, the entered email in this example and the validity of the email, that clearly kind of belong together and which we therefore might want to manage together. In addition, I want to come back to something which we don't have anymore because we're using useEffect, but what we had before. If I comment out useEffect here, before you might remember that inside of email change handler and password change handler, we had a slightly different code. We had this code here essentially, not just in the email change handler, but also in the password change handler, where we checked the other entered value and the entered value for this handler with event target value, and we would derive the form validity from that. Now, this approach also worked, but we had some code reusage, which is why the effect was a better result. But let's say for whatever reason you don't want to take that route to use effect. In that case, you would have another problem, and I'm just going back to the solution to show you this problem, which you can have in some apps and in some use cases. Here, we are updating some state, the form validity state, based on two other states. Now, what did you learn about updating the state based on some older state? You want to use the function form, right? Now, this doesn't work here, however, because that's only true if your next state update depends on the previous state snapshot of the same state. But here we depend on two other state snapshots of different state, of the entered email and the entered password, not on the last state snapshot of the form validity. So therefore here actually we're doing something which you normally shouldn't do. Because of the way React schedules state updates, this code here could actually, in rare cases, but it could actually lead to the scenario where this runs before, for example, password state update was processed. So therefore entered password, when this code runs, might not contain the latest entered password, because of how React schedules state updates. That's what I preached before and why I urged you to use the function form. But again, it's not available here because we're depending on two other states and not the last snapshot of this form validity state. This is another scenario where you could use useReducer. So it's a good use case, a good replacement of use state when you have state that belongs together, like here with the entered value and the validity of the value, and or if you have state updates that depend on other state. And actually, we don't even have to go back to this code. We already violate this rule of using the function form if a state update depends on an older state here in our validate email and validate password handlers. There we are calling setEmail is valid and setPassword is valid to set new states for this email is valid and password is valid state. These are our two states which we're setting there. Now, how are we setting these states? Well, by having a look at another state and calling a method on it. So we're having a look at the entered email state, which is a different state. This is our entered email state. It's a different state than our email is valid state. Sure, they are related. They both change because of what the user entered. But technically, these are two different states, two different variables. And we are deriving our new email is valid state by looking at another state. And that is something we should not do. It works in most cases, but in some scenarios it could not work because maybe some state update for entered email wasn't processed in time. And then we would try to update email is valid based on some outdated entered email state. So we should use the function form here, but again, just as with setForm is valid, we can't, because with the function form of our state updating function here, we only get the latest state for that state which we're setting here. So we would get the latest email is valid state, not the latest entered email state if we use the function form here. So that's why this is not an option. And therefore here we are already violating this rule, which I told you to, well, not violate. And that is a scenario where useReducer is always a good choice. If you update a state which depends on another state, then merging this into one state could be a good idea. And you can do that without useReducer as well. You could simply manage an email state, which is an object with the value and the valid being part of the same object. You could do that with use state. But in such cases, when your state becomes more complex, bigger, and combines multiple related states, useReducer can also be worth a closer look. And that's why we'll dive into it in the next lecture.